This is Chris from the Ela Public Library Makerspace, the Forge, and we're going to go through how to use Tinkercad today. We're going to be using this web-based 3D modeling program to design sort of a basic house object, which will help you kind of learn how to manipulate objects, how to move the camera around, and design your first 3D model, as well as how to submit it to the Ela library for 3D printing. So the first thing that you want to do is go to tinkercad.com, tinkercad.com, Tinkercad. If you don't have an account already, you can create one for free. If you are under the age of 13, you will need to have your parents help you out. So you will be able to create an account, but you won't be able to follow along with our instructions. You'll only be allowed to do the tutorial that is pre-built into Tinkercad until your parents contact the company and authorize your account. Or you can use your parents' account if they have one. That works too. So I'm gonna switch over here to my account. So the join now and sign in buttons are in the top right corner there, and you would log in and you will see something sort of like this, with way less projects all over the place. You'll probably also get a pop-up if this is the first time you're logging into Tinkercad that says, hey, do our tutorial. You can close out of that with a little X button in the top corner of that pop-up. And if at a later time you want to come back and do those lessons, they will be under this Lessons tab here on the left-hand side, and it'll be My First Lesson. But for now, what we're going to do is we're going to click on this blue button up here that says Create New Design. And you can kind of see down here, this design is what we're going to be building. I've taught this one a couple of times now, so. Alright, and it's going to load up here and give us our workspace. So we're going to go through the user interface of what everything does before we start building stuff. So up here in the top left corner where it says Tinkercad, if you click on that, it will open up your dashboard and bring you back to where you're working on stuff. And I need that open because I'm going to cover something here in just one sec. So next to that is our randomly generated name. And so what we want to do is we want to click on that, and it becomes a text field that we can type in. So what I'm going to do is type in Ela Library 3D Model Intro, and then hit enter to save it. You can name your project whatever you like. I'm naming this because this is what we're working on today. And this is one of the reasons why I also needed the dashboard open. Is I'm going to open that back up here real quick, and I don't remember what Fantabulous Crunk Magello is, or Fantastic Rodus Snicket. I don't remember. And I would have to load those models in order to get an idea of what it is. You're better off getting into the habit of naming all of your projects, so that way you don't run into this problem of a couple months later you don't see what the model is because it's not rendering anymore. So learn from my bad habits. Don't do that. Name your projects. Okay, so after the naming field, let's talk about this bar down here. We have some quick keys. So we have a copy, which Control-C or Command-C if you're using a Mac will let you do that as well. Control-V for paste, again, Command-V in a Mac. Control-D for duplicate and repeat, which is just basically pasting, deleting, and then there's an undo and redo button. Undo and redo are the best tools. They're super, super useful because let's say you're working on a project and you've got everything lined up and you're like, hey, you know what? I need to move this part, this whole thing together over a couple more millimeters to make sure that it lines up with something else. And you click on the wrong thing and oh no, you just undid all of that work that you'd been working on. But you can click undo and it will snap things back one step. And you can keep undoing until there's nothing left to undo. And then you can redo until you're caught back up. There are limitations on this, so you might want to experiment with it and tinker with it just a little bit to get a feel for the limitations. So I'm going to delete, or actually I'm going to keep these objects because I need them for another example in just a moment. So beneath this bar here, there is this little cube here, and you can notice there's a little blue icon just kind of popping around wherever we mouse over. So what that does is it's telling us where we're going to be holding this box and where we're going to be turning it from. And then this is kind of an alternative way to rotate the camera around, and it'll also tell you, oh hey, now you're looking at the top, looking at the bottom, front, left, back, so on. So we can kind of just move the camera around here. This is really helpful if you're using a touch device, like an iPad or something along those lines. But you can also right-click and drag with your mouse to do the exact same thing. And it's a little smoother with a mouse. So if you have a mouse, that's super useful. Okay, so I'm going to turn our camera on a diagonal, and I'm going to zoom out a whole bunch. For our next button here, beneath this cube, is a little house button, and that's our home view. So when we click on this, it's going to snap the camera back to its original location. It's very helpful if you're panning around and moving stuff around. Speaking of panning, if you hold the Shift key down on the keyboard and then right-click and drag, you can pan the camera. This is a very helpful feature for you to be able to get a better view of what you're working on. So Shift key and right-click drag to pan. Okay, so I'm going to grab our sphere here. I'm going to move it off to the side. So our next button here, Fit All in View, is a modal button. It'll do two things depending on what you're working on and what you do. So right now, without anything selected, it's a Fit All in View function. If you click on something, that button changes to fit view to selected shapes. So what does that mean? So we're going to move our cube over here. And so when we click on this button with the cube selected, it's going to snap the camera just to that object. And it's going to ignore everything else. Now we can always zoom out and move the camera around, but that view is going to immediately move to whatever it is you have selected. Now, with nothing selected, Fit All in View will zoom back out until every object is visible. Now, why is this useful? Well, let's say you're working on a project, and early on in the project, you have this little triangular roof, and you're working on it, and you're cutting off sides, and you're building up on it, and you're doing all sorts of project work on it, and you go, you know what? I think maybe I should have started with a sphere instead of a triangle. And you go, well, I don't want to lose all this work on this triangle. Maybe I can repurpose it for something else later on. So what you do is you grab it, and you drag it off to the side so it's not in your work area, and you don't have to worry about it, and it's not in your way. And then you're working on that sphere and so on, and you're like, okay, my project is ready to go. I'm going to submit it. If nothing is selected, so if you don't have any objects highlighted, when you export your model to be 3D printed, it's going to default assume you want everything in this project to be part of the 3D model to be printed. Now, when we hit Fit All in View, even our triangle over here is still part of the model. So all of this distance between this and this, that will be counted as space required for the 3D print to work. Meaning, our 3D printers at the library will go, oh, wow, that's way too big for us to 3D print. That's huge. We can't print it, even though this is all blank space. It's assuming the distance between those spaces is important, because in most models, it is. So there's a couple of things that we can do to circumvent this, and we'll talk about it as the project goes on, but using the Fit All in View function can be very helpful to make sure that everything is accounted for in your workspace. Now, if you have multiple objects way out of your field of camera, you can still hit Fit All in View, and it'll pan out and show you everything. So let's delete all these for a moment, and then we'll hit our home to get back. There we go. Okay, so moving on. We have a little plus button and a little minus button, and those will function the same as scrolling in and out with the mouse wheel for zooming in and out. Again, this is a function that's pretty useful for touch screens, where pinch zooming is a little more difficult. Okay, so I need to grab a couple of things here real quick. So right now, our camera is in what's called perspective mode, meaning as we get farther away, things become smaller, and as we get closer, they become bigger. And our field of view kind of changes as we're moving the camera, and so do the shapes. The next button on this, orthographic view, is an interesting button. It's also called flat view. So when we click on this, the camera is going to change. And me personally, I don't find this super helpful, but I'm sure there's someone out there that would find this useful. So I'm going to highlight this function just in case you out there find this to be super useful. So as you can see, the camera perspective gets very different when we hit that orthographic view. Our work plane is kind of slanted on diagonals, and I'm going to switch it back to perspective. And we're going to be doing the rest of our project in the perspective mode. So I'm going to delete these. Okay, so there's a couple more things that we need to cover before we start getting building. So we have a group function up here, an ungroup function, and we're going to talk about those as we continue. A line, which is like one of my favorite tools. It's super, super useful, and we will be working with this as well. And then we have mirror. So mirror is a really interesting tool that we're not going to be using on this project, but I do want to highlight it because it's super handy. So let's grab these. Okay, so I'm going to do a couple of things real quick here just to kind of highlight what the mirror function does. So don't worry about following along on the steps that I'm taking right now. I'm just doing it to make an example, and we'll talk about it more later. So when we click on mirror, we get these little handles, and handles are super important for Tinkercad. We'll be talking a lot about different kinds of handles and what they'll do to an object. So when we mouse over them, these bottom ones, we don't really see anything changing other than a light orange sort of ghost popping up over the object. But when we click on, hover over this one, we see that if we were to click on this, it would flip the cone because it's mirroring it. Now, if we do the same with our different shape over here, our icosahedron that's all cut up, we can see, as we mouse over stuff, that it changes. So if you make a piece and you're like, oh man, I need another one of those in exactly the right way, you can copy, paste, and then mirror it to flip that object and be able to have another one of them. Okay. There's an import button for bringing models into Tinkercad, so if you find something online that you want to modify or edit for your own purposes, that's super helpful. There are limitations on that size-wise and also with how densely the object is rendered, so not everything will work. Next is export, and that's how we will save our model out to be 3D printed. Tinkercad is web-based, so it'll constantly be saving. Every time you make an edit, it will save it to your model, so that way you're not going to lose any work if you suddenly lose your internet connection or if your computer runs out of battery or what have you. Exporting is just for saving it to your computer and making it 3D printable. Work plane is another function that we'll talk about in a little bit. This lets us move where this base of the work area is in relation to other objects. Okay, and then we have our toolbox here. So when we click on this with the left mouse button, we have a huge list of all sorts of really cool stuff in here. So there's text and numbers, characters, which have like little bits and pieces for making like action figures, like glasses and sunglasses and mustaches. There's stuff from the Smithsonian Institute museums in DC. These are very recent additions. We have, there's a page motor, a Morse telegraph. Let's grab that telegraph real quick and let's see if it'll load in. Come on. There we go. So when you click in an object, sometimes if it's very complex, it'll take a little bit to load. But that orange ghost that we see here is where this object is going to deploy when we let go of the left mouse button. So I'm going to delete one of these. Now this is a solid object, meaning that, let's zoom in here nice and close. These screws here will not come undone. They're just part of the plastic. They're just sort of like a decoration. This lever here, this spring, is not going to bend. It's going to be solid. Same with these hinges here. They're going to be single solid pieces. Now that's not to say you can't design and print hinges. You totally can. It's just very difficult, and this is not a model that's already built for that. It's just kind of a scan of a real life object. So let's delete that, and we don't want work plane. There we go. Let's jump back to basic shapes and get started. Actually, I fibbed. We're not getting started just yet. There's two more little things that we need to cover before we get started. On the toolbox here, there is a little arrow. If you click on this, it will hide the toolbox and give you a little more screen real estate. So if you're working from a computer and also watching this video, you can pause, jump back and forth to have a little more space, or you can break up your windows so that way you can see both tabs at the same time. You can use that to kind of give yourself some more 3D modeling space. Beneath that, there are two more little buttons here. There is an Edit Grid button, and there is Snap Grid. So we're going to leave Snap Grid on 1 millimeter. So what that means is each of these teeny tiny little squares inside of these bigger squares, that's 1 millimeter. So whenever we move something, it's always going to move in increments of 1 millimeter. We can adjust that to turn it off or to have it to be 0.1 millimeter or anything else in this whole list. So if you need to adjust something to be more accurate or more precise, you still have that option. But we're going to stick with 1 millimeter today. And then there's this Edit Grid button. We're going to click on that with the left mouse button. And we're going to have this grid properties pop up. So there's a bunch of information in here that's super important for us. So right now, it's preset to the defaults of a 200 millimeter width and a 200 millimeter length for the blue work area. Now that's not to say that we can't also work outside of that area, but this is the area that will be part of the work plane. So there is a drop down here that says units. You can click on that. There's inches and bricks. I'm pretty sure bricks are Lego bricks. We want to leave ours in millimeters because our 3D printers work in metric. They are set to millimeters by default, so we don't want you to have to go and do a bunch of conversion math in order to do your project. So just leave it in millimeters and you're good to go. What we do want to change is this width and length. So we want to click in these text boxes and delete what's in there and type 145 for our width. And we want to do the same for our length, 145. Now, 145 is 145 millimeters. So our 3D printers at the Ela Library, we're using Lulzbot Mini 3D printers, and their maximum build area is 145 millimeters by 145 millimeters on the X and Y. That means the flat surface of it. And then the maximum height we'll cover in just 1 second. But if we switch this, and you stay within the blue perimeter once you've switched this, you should be solid to make sure that your print actually fits on our 3D printer. Now, we need to click this Update Grid button. If we click outside of this box, it will not save our changes. If we click Cancel, it will not save our changes. Same with this X button up here. It won't save the changes. So click on Update Grid, and then you'll see this blue background get a little bit smaller. Okay, so now our work plane is 145 by 145. Now, maximum height. I'm going to drag something in real quick. Our maximum height for our 3D printers is 150.7, if I remember correctly. So we can get pretty tall. There we are. Now, if you're concerned about your project being too tall, you can drag in something and put it to the maximum height and then know that, oh hey, I can't build anything bigger than that. So we're going to delete this, and we're going to talk about objects now and start working on our project in earnest. So, all of our tools over here, all of these objects, when you mouse over them, you get a little blue box that says, hey, that's the thing you're going to click on and select. And then you left click with the mouse and drag into the work plane, and then you get this orange outline of the object wherever you drag your mouse pointer while still holding that mouse button down. And then when you release the mouse button, it will pop in to the work area. Now, if this is the first object you've brought into the work area, this shape drop down will probably pop open automatically. So this is another one of those features that is very helpful for people using touchscreen devices. So there are different sliders here that you can tap and adjust, or you can click in the text over here on the side and type in measurement changes. Or we can do that just in the work plane itself. So if you don't want to use this, you can just click this little black arrow up here and it will shrink it down. And we will talk about the color and this striped box here in a little bit. So let's talk about our object. When we click on it, actually, what I want to do is I'm going to grab another object, and you don't have to do this part. This is just me highlighting something. Okay, so when we click on an object, you should be able to see this light blue outline around the object, and our orange cylinder here will kind of help highlight that bright blue. So when that happens, that means that this object here is selected in comparison to clicking on that orange one. Okay, so when we click on an object, we get a series of handles that all pop up. So we have little black handles, little white handles, little cone handles, little curve handles. Okay, so let's get rid of our cylinder friend there. White handles, when you click on them, will show you the width and length of an object here on the ground, and if you click this one up here, it will show you the height of the object. If you left click and drag on this, it will change multiple sides at the same time. Alternatively, you can left click and drag on one of the black ones and it will just change one side at a time. And this white one at the top will just change the height. Now there's a way to change the height, width, and length simultaneously, but we'll cover that much later in our class. Now, there are also little curved handles here, and if you left click and drag on them, a couple of different things can happen. So if your mouse pointer is inside of this blue circle on the ground, what will happen is when you rotate, it will move 22.5 degrees every time. So this is so you can get a nice 45 or 90 degree turn on an object. Now, if your mouse pointer is outside of this blue circle, you can see that it's moving in 1 degree increments. So if you need to be more precise with how you're rotating your object. We're not going to be doing rotation in this project, but I just wanted to make sure that you knew about it. So it's not just for this base here, but also you can rotate on the sides, like so, and also on this side too. Alright, I'm going to use our undo feature to snap things back to where they were. Alright, there's one more handle here, and it's this little black cone, and you'll see that it highlights red when we mouse over it. If we left click and drag on it, you can see a new measurement pops up. And as we lift it up, you can see there's a black line on the ground and another black line that's attached to the bottom of the object we are lifting. This cone is for elevation. So what this is saying is right now we are 13 millimeters off of the ground. So when we let go of this cone, a shadow pops in underneath that basically says, hey, this is floating in the air. Now, we need to be careful when we're building objects that are not supported on their base, because we have gravity here on Earth. And when we try to print something against gravity, gravity takes effect and pulls the material down to the ground. So if there's nothing to support the object, if there's no base, we just kind of make a big stringy mess with our 3D printer. Now, there are a couple of ways that you could print something that's above the ground. We could use support material, or you could build your own supports. There's a bunch of different things that could be done, but we're not going to be doing that here in this class. So, I'm going to hit Control-Z to drop our box back down to the build plate. Okay, so the first thing we want to do with this box, now that we've covered how all the handles work and how to rotate it and all of that, is we want to click on one of these little white handles, and then in this text box that pops up, we click inside of there and we type in 40. And then we want to do the same with the width, 40. So our width and our depth are 40 and 40. And then we also want to do that with our height. So we want to change that from 16 or whatever number yours is currently at to 40. So right now we have a 40 millimeter by 40 millimeter by 40 millimeter cube. So this will function as the basis of our house. Okay, so right now we know how to manipulate the camera. We know how to bring objects in. We know how to identify how big an object is and how to modify that. We know about object rotation, and we know about the touchscreen camera controls before we move on. So, I'm going to grab one of these little green roofs here and drag it in. So I'm going to show you one way to do it, and then I'm going to show you another way to do the exact same thing using workplane. So, we bring it in, and we want to turn this to be 40 millimeters on the base by 40 millimeters. So we can click on one of these little white handles, click in the text box, and type in 40. And now my text box is a little bit far off the screen, so I'm going to move my roof so my text box is back. So right now these two objects are clipping into each other. So if we sent this into print, it would be all one object. There wouldn't be, It wouldn't separate them, it wouldn't move them apart, it would all be printed exactly like this is right now, which is not what we want with a house. Having the roof on the ground is generally a bad thing. So we're going to move this box over just a little bit. Now, we can use the elevation cone here, and we can lift our roof up. So we know that our cube over here is 40 millimeters tall, so we could just type into this elevation box 40 and immediately lift it up to the correct height. Now, this is a pretty easy thing to line up manually because they're both the exact same width and length of each other, so we can just kind of square them up with each other. But if we have objects that are not inherently the exact same measurements, what we can do instead is we can use the align tool that we talked about earlier up here. So, to use this tool, what we would do is we left click with the mouse button and hold that button and then drag the mouse, and then you will see dotted lines start showing up in a box. We can drag this and kind of lasso multiple objects together, and then when we let go, it will highlight all of the objects that were selected. So now both of these pieces are selected, and I'm going to click off of them for a moment. You'll notice up here on our toolbar, these are all grayed out right now, and then when we left click and drag, our group and our align and our flip, our mirror, all highlight, meaning that they're able to be used. So we're going to click on align, and we get more handles. Handles are super helpful in Tinkercad. So these handles will show how the align will work. So if we mouse over them, it will show us an orange outline of what will happen when we click on them. So if we click on this, it's going to yank that roof back down to the ground. If we click on this, it's going to yank the box up, so the top of the box is the exact same height as the very top of that roof. Now that's not what we want to happen. So we're going to ignore this whole side of our tools. Now, if we mouse over these ones in the middle, it'll show you other things happening. So let's click on this one down here, and hey, it's snapping those pretty close and nice and neat together. And if we click on this one, ta-da, we have a roof on top of our house. Now, these are two separate pieces still. If we click and drag on just one part, we can still separate them. And undo will snap it back to that previous step. Now, we can left click and drag again and highlight everything, and that group button also shows up. So if we click on that, it will lock these two pieces together and make them a single piece. So no matter where we click on it, we're selecting that. Whoa, it ungrouped. That was weird. Tinkercad was just having a little bit of a fit there. If we left click and drag, no matter where we're clicking, if we click on the base, if we click on the roof, they're all one piece still. But we can always click on the ungroup to change it. So let's say we made the roof too small or too big. We can ungroup them and modify it, and then group them back together again. Okay, so I said that I would show you two different ways to get this roof on top of this box. So I'm going to delete the roof that we have right now, and I'm going to click on Work Plane. And when I drag the mouse back in, you'll see this little blue box is following my mouse pointer around. And when it gets close to an object, it turns orange and magnetizes to the surface that it's closest to. I'm just going to pivot the camera here so you can see that it's jumping around all over the place. So if we click on the top of this box, our work plane down here is going to jump up to here. Just like that. So now, when we bring anything in, it's going to be at 40 millimeters height. So now our roof is on top of the box. And then we can change the width and the length to get it to fit. And then if things aren't quite perfect, we can still make use of our align tool and line it all up nice and neat. There we go. And then when you're done using the work plane tool, what you would do is you would click on the work plane tool again up here in the corner, and then bring it back in and click anywhere that it'll show up blue. So right now it's showing up orange, orange. It shows up blue down here. Click, and it will snap that back down to the base again. Okay, so I'm going to group these together. And so now we know about using the work plane tool, we know about using the elevation tool to lift things up, and we know about grouping, ungrouping, and aligning. And now we're going to work on our next step. So right now we have walls for our house, we have a roof, but we don't have a door. We can't get in the house. Kind of important. So I'm going to grab another box, and we're going to talk about this shape tool up here. Now, you may have noticed there's a box with stripes across it, and a cylinder with stripes across it. And this shape tool also has a button with stripes on it. So we're going to duplicate our box here real quick so we have a point of reference. So right now, these are both red in this little box here. If you click on this, there's a whole plethora of colors in here. There's also a transparent option. These are all still solid. What that means is that this is a solid object, that when we put it through our 3D printing program, it's going to make that object. Now, if we click on this other button next to it, and it says change to whole, when we click on it, it turns transparent and it has stripes all over it. This is negative space. It is a hole. If we sent just this piece, just this striped box, to our 3D printer, absolutely nothing would happen, because our printer would go, yeah, that's a hole. I don't put material down in negative spaces, so I guess the print job's done, and nothing would be printed. But we can use this to cut into things and make complex shapes. So one such example is we could rotate our box 45 degrees. And again, this is something that I'm just using as an example. You don't have to follow along with this step. But we can group that, and we can make different shapes, not just a cube, but we could start making any kind of complex shape. Let's undo that. Let's get rid of our solid box, and let's keep our hole. Now, what we want to do is we want to change the height of this down to 15. So you can click and drag or just type in the little text box there. We want to change the width to 10, and then we want to change our depth to 15. So right now, it's 10 millimeters wide, 15 millimeters deep, and 15 millimeters tall. So I'm going to zoom in close to our little house here, and I want to show you what happens when these surfaces start to intersect. So right now, nothing is happening because they're not touching. But when it touches, you're going to see just a little bit of gray there. And as we move, you'll kind of see that gray flickering. That means that they're touching, not that they're cutting into each other or breaking. Now, when we move the box in, you're going to see something happen. See that gray that popped up? That means it's starting to cut into this object. So, no matter where we put it, it's going to cut a hole. But if we put it in too far in, it's just going to cut a hole and not give us a doorway. So I'm going to hit Control-Z to pull it back out. And where you want, you can move this wherever you want. You can put your door over here on the corner. You could put it in the center. You could use the Align tool to align it exactly center if you really want. You could put it over here in a corner. It's entirely up to you. But you want to have it so just a little bit of it sticking out like this. And then you'll left click and drag to highlight your door and your house, and you will group it. And then you will see that cut being applied. So we have our little doorway here. Now, I've had people in the past ask about making an entire floor plan and individual rooms and things like that in a model like this, and that's totally possible. But what you would want to do is you would want to make each individual layer their own separate model and then be able to glue them together or stack them together. Because, again, you would be printing over thin air if you are trying to make a two-story building like this. So we're not going to do that. We're just going to focus on the exterior shape in this class. Alright, so now we know about solids and holes. We know about applying cuts to an object on top of everything else that we've learned. So the next thing we want to do is make a little garage for our house here. So we're going to grab another box and we're going to drag it in. And this is up to you where you want to put it. You could put it on the left side, you could put it on the right side, you could put it behind your house, however you want. So I'm going to put mine on the left side here and let go. So right now, they're not touching. They're not connecting at all. So let's zoom in our camera. And I'm going to move this over. So, depending on your perspective and where your camera is placed, so if I have it tilted like that, that might look like that they're connected to each other. They are not. If we were tilted this way, that kind of looks like they're connected to each other. They are not. So we want to zoom in and we want to move the camera around, and you can see there is a gap there between the two of them. So then we want to move this a little bit closer. So that way they are touching. It's very important to move things around so you can get multiple views of your object. So the next thing I'm going to do is I'm going to grab one of these striped boxes here and drag it in. So right now, our garage is a 20 by 20 by 20 cube. I'm going to make this hole 19 millimeters tall and 18 millimeters wide. Let's zoom out so we can actually see that text box there. So if we line this up with our garage and we start putting it in to the garage, oh, I want to make the depth also 19. Because if we push this cube all the way into our garage, and so long as we're lined up correctly, right now we are not lined up correctly. Let's undo that. That's better. So if we do that, where it's gray and kind of flickering there, that means that entire transparent box is inside of this larger box. So we have a 1 millimeter roof, we have 1 millimeter walls, and because this is 19 millimeters deep and the cube itself is 20 millimeters deep, we will have a 1 millimeter wall on the back when we group these. So we'll left click and drag again to grab both of them and hit the group button. And ta-da, we have a little garage there. Now, again, artistic preference. You could ungroup this and you could undo that move. No, let's undo a couple more steps. There we go. Now we have our box back. And you could put it on an angle to have an awning. Or you could make it longer than the part that is solid, so that way you have kind of like a carport where it's just a little roof over the area. Or you could use this as the basis for a second floor patio. Whatever you want to do, you can do with this 3D model. However, I am going to wind it back. Well, let's just do it this way. That works. And then we will group them together. Okay. So this is a pretty plain little house, but you can come back to your project and you can embellish it more. So you could go and build a chimney for the roof, or you could build an observatory, or you could go and find other pieces on Tinkercad and import, or Thingiverse, and import them into Tinkercad to use. There's all sorts of stuff that you could do with it. You could go and model little doors for your house, and you could go and put little pinholes to put hinges on the doors. Sky's the limit, really. The thing that we're going to do next, though, is we're going to make a welcome mat for our front door. So we're going to grab another box here, and I'm going to stretch it out so it's 30 millimeters wide. Yeah, let's do 30. This is a really big welcome mat. I'm still going to leave it 20 millimeters deep. But I'm going to change the height of it down to 5 millimeters. Let's bring it down to 3 millimeters so it's not super thick. Okay, so we have a little welcome mat here. Let's put some text on it. And we have in our toolbox a text tool. So I'm going to zoom out because the text, when we bring it in, is going to be super big. It's way too big for our little mat there, but we will work on it. What we want to do next is click on this shape tool up here and open it back up. And with text, we get different options than what we would for other solid objects. So we have our text field, so we can edit what it says. We have a font field, so we can change what the type of font is on it. And then there's height, bevel, and segments are all part of the previous ones as well. I'm just going to leave mine on multi-language here. So in the text field, I'm going to type in welcome in all, let's not do it all caps. We'll do it just regular. And I'm going to put an exclamation point at the end of mine too. So when we click away from that, it'll close it back up, and we have our text. But this is way too big for our little welcome mat. So what we're going to do, I'm going to shrink this down first, is we're going to work with proportional transforming. So what does that mean? We're going to change the width and the length at the same time as we change the height. So the first thing we want to do is we want to click on the height. Right now it's set to 10. We're going to lift it up to like 50. 51's fine. And then what we're going to do is we're going to hold the shift key on the keyboard, and we're going to left click and drag on that height again. And we're going to drag down. And what you're going to see is the width and the length are also changing at the same time as the height. This is changing proportionally. So right now it's still too big for our mat. So I'm going to left click and drag the whole text and bring it up to the mat. There we go. I'm going to lift it up a little more so it's taller. And that's without holding the shift key. And now I'm going to hold the shift key again, and then left click and drag down again. And then let go of the shift key, drag up, hold shift key, drag down. I'm going to zoom in a little bit, take a closer look at our model. So right now, we're fitting pretty okay. I'm gonna make it a little bigger. And that's again shift and dragging up to make it large proportionally. And then I'm going to scooch it over just a little bit. Or I could use the align tool to line it up all nice and neat. But I'm just going to scooch it. It's fine. So our text is way too big for this mat. So what we'll do is we will click on it and we will drag that height down much lower. So our base of our mat is 3 millimeters tall. So I'm going to drag our text down to 5 millimeters because 2 millimeters is going to be poking up over this 3 millimeter mat. So we have a little welcome mat. Now, let's say you don't want the text raised, but you want it cut into the mat. There's a way to do this. If we group them, if we click on that text and turn it into a whole, and then group it with the mat, let's click on our group there. It cuts all the way through the mat. And what's going to happen when we print it is the interior pips for the E, the O, and the other E over here are going to be separate from the rest of the mat. They're not going to be attached in any way, shape, or form. So those will kind of get lost or not be attached to the rest of your model. Now, there's a way to fix this. You could make really small walls that connect them to the rest of your model, kind of like a stencil would have. That's kind of tricky, and depending on how small you're making your walls, they might be too small for the 3D printer to recognize. So what we're going to do instead is we're going to ungroup our text from the mat, and then we're going to lift just the text up 1 millimeter. So what that means is there is a whole millimeter being printed of our welcome mat before it starts printing and leaving the negative spaces for our text. So when we group these again, and when it renders, it's going to show it embossed into the mat, but it's not cutting all the way through. So these interior pips are still part of the whole solid object. So we've got a welcome mat, we've got a house, we've got a garage, we've got doors. It's a pretty good start for a 3D model. So we're going to leave this alone for now, and we're going to talk about exporting and uploading your model to be 3D printed at the Ela Library. So up here in the corner, we have our export button. When we click on it with nothing selected, so right now nothing's highlighted, if we click export, it's going to default to everything in the design on this pop-up here. So if we grab our sphere and throw it a million miles away like we did at the beginning of our project, and we don't have anything selected when we click on that export, everything in the design also means our sphere that's all the way out here. So we're going to delete this. And I'm going to hit the home button again to bring our camera back. So if we have something selected, so right now we just have the house and garage selected, not the welcome mat. If we hit export, it's going to say the selected shape, meaning it's ignoring the rest of the stuff. Now, if we hold shift and click on the welcome mat and the house, both of them are selected. And we'll see up here in the shapes tool, shapes 2. That means 2 things are selected. When we hit export, only the selected 2 shapes. So this is a way to ignore pieces that are like scraps from earlier iterations of a project. You can always click on that everything in the design feature and just kind of bypass that too. Okay, so besides these little radio buttons here, we have a bunch of other buttons. So we have for 3D printing, we have .obj and .stl and .glb as options. OBJ and STL will work out perfectly fine with the 3D printers that we use at the Ela Library. We use Lulzbot Minis, and we use Cura as our slicing program, and it understands both OBJ and STL. I've never seen a printer that uses .glb. I think maybe that's for resin printers, but I'm not 100% on that. So you can click on either OBJ or STL to save the model for printing. .svg for laser cutting. We do have a laser cutter at the Ela Library, but it's not available for patron usage just yet. So we're not really going to talk about that on this project. So I'm going to click on .stl. Oh, before I do that, there is another option here. Up here it says 3D print. If you click on that, this will tell you about other services that will do your 3D printing for you. And I'm willing to bet they charge more than your local library does for 3D printing. So we're going to stick with download rather than going through a third-party service. So we're going to click on .stl, and you will get a pop-up saying, hey, where do you want to save this model? So I'm going to save mine just to my downloads folder, and the name of the model will be the same name that you have up here. So mine will be saved as Ela Library 3D Intro Model. So I will save mine. So now that our project is saved, you can see that down here. It showed up in our browser that it's saved. I'm going to jump over to our library webpage, eapl.org. So we have a whole bunch of information on our library webpage about the different services and digital services that we have. We want to go down to Create and mouse over it, and we get a pop-out here that says Digital Media Labs. And if we mouse over that, we get more info about that. The Digital Media Labs are on the second floor of our library and have green screens and video cameras and microphones and all that stuff for patrons to use in library for digital media work. Beneath that is a pop-out for Forge, and we'll talk about that in just one more moment. And then beneath that is Creative Bug. Creative Bug is a service that our library pays for, that our patrons can make use of. It is a video tutorial series for all sorts of different projects and crafts. It's very, very neat. So when we mouse over Forge, we get a pop-out with 2 more options. 3D print job submission, which we will be clicking on in just a second, and Forge certification. Forge is our makerspace, and Forge certification is learning how to use some of our more advanced tools in the space. So we have 2 silhouette cutters, we have sewing machines, we have Wacom digital drawing tablets, things like that. So you can sign up for an appointment to be shown how to use those tools with that Forge certification form. And then when we eventually make the laser cutter available for patrons to use, again, it would be something through there. But right now we're going to click on this 3D print job submission button, and it will open up our form for sending in our 3D print job. Here we are. So this is a very information dense page right now, and we're going to be editing it soon. But right now we have info about how much it costs to print your object, which is 10 cents a gram. STL and OBJ as our file formats. The maximum workable area for our 3D printer. This little infographic here says, do not click on the upload button down at the bottom of the form. This is something that we're going to be editing, and I just want to highlight it, because if you do click on it, it breaks your submission and we'd never see the email saying, hey, print my thing. Beneath this, there are little links here to other tutorials that we've taught on how to do 3D modeling. There's an intermediate, there's how to design the Willis Tower from the Chicago skyline, the Hancock building again from the Chicago skyline. These are saved as PDFs. You can click on them and download them and go through them at your own pace. Beneath that, there's a picture of some of our color samples. This is going to be edited in the near future because a bunch of our color samples have kind of swapped out. And then if we scroll a little further down, we get to the important part, our form. Enter in your name, so I'm going to type in Ela Library Forge as my name. You would want to put your real name here. Your library card number, you would need to fill that out. If you are not an Ela Library card holder, if your library card is registered with the Ela Library, so let's say your home library is Wakanda, but you're registered with us to borrow books, guess what? You can still submit your model to be 3D printed. Or if you're from Barrington or any of the other libraries that are part of our consortium, if you are registered with Ela to check out books, you are registered with Ela to 3D print with us. So you'd put in your library card number here. Beneath that is a radio button that says whether or not you want us to put your object on display. So we have a display case and we have acrylic risers on order, and we want our patrons to know all the really cool stuff that you can build with a 3D printer. If you don't want your project to be shown because it's a surprise or it's a gift for somebody, or you know what, this is just a rough draft and I'm not really ready for other people to see my project, you can always click on no and we will not display your object. It'll be in a locked up cabinet waiting for you to come and pick it up. Email address is super important because that is how we're going to contact you when your project is done, or if there were any hiccups with your project along the way, like it was too big or there were other problems with it. If there is an issue with your 3D print, we will take screenshots and try our best to explain what went wrong so that way you can modify your project and then resubmit it so we can get going. Phone number is optional. You do not have to fill that out. Beneath that are our color options. So we can only print with one color at a time. It's kind of like a mechanical pencil, but with plastic. So if you pick Goldsbach green, the whole model from top to bottom is going to be that one color. Now you could always paint your model afterwards with some acrylic paint. It sticks really nicely to the 3D prints that we make. If we run out of a color that you've selected, we will email you and say, hey, we ran out of that one. Will a different color work? Or do you want to wait and see if we can get that color back in stock? Next is our upload. So you would click on this choose file and a pop-up would show up to ask you where your project is, and you would select it and then not click the upload button. If you click the upload button, it will break. Beneath that is a comment section. So examples like email me an estimate before printing, or if you run out of blue, green is fine, or I don't care what color is printed, things like that. Any comments that you want to communicate with us before we print your project should be put here. And then there is a CAPTCHA down here that you need to fill out. And then you click on this submit button once, and after a few moments, your email will arrive in our inbox saying, hey, print my project. And we will load your project up in Cura, our 3D printing program, look it over to make sure that it'll fit on our printer and that there aren't any problems with it, and then belt it out as soon as we can. And then the moment it's done, we'll send you an email saying, hey, come on into the library and pick it up. So thank you very much for watching our little tutorial here on how to use Tinkercad to design a little 3D model house, and hopefully we'll see your project soon. Have a good afternoon.